We've got some pretty big news today. I don't know how many people know this, but Flyte has not until now included its own native scheduler. We've always relied on an external scheduling service from whatever host provider we were on. But Praful's going to be showing some work he's done over the last couple of months to fix that and include a baked in, fully performant, scalable scheduler that will become just part of the Flyte standard distribution that can be relied upon without an external dependency. So we've shed a dependency, which reduces complexity in the system and helps sandboxing and sort of everything else for it to feel like it's a completely integrated piece of the system. And people have been asking for this for a long time, and Praful stepped up and built it. So I'm going to let him take it away. I think you're muted, my friend.
Hey, thanks, George, for the introduction. Yeah. So my name is Praful. So I've been working on the Flyte native scheduler. I think the requirement is pretty clear for everyone. We have been supporting this through AWS, and most of the examples that we currently have cannot be run because most of the folks, when they first try out Flyte, they need a sandbox environment. And in the sandbox environment, they cannot try this particular feature. And so it's kind of a main feature that people want to try out before accepting or ongoing with Flyte. So instead of deploying an AWS setup right now, we natively support a scheduler that comes up in the sandbox deployment and can be used later on, can be replaced in GCP or any other cloud provider that Flyte is being deployed on. With that being said, let me just share my screen and just go over some of the aspects of it. Just a second. You guys can see my screen? Cool.
Yep.
All right. Yeah. So what are schedule execution? So any ML or any workflow engine, you definitely need a ways for executing some of your tasks or workflows on a certain cadence or a schedule. Like you have a monthly job or a daily job, or something you want to run every few minutes or every few minutes or at a clock time. And these can be database jobs or any of the ML pipeline jobs that are needed. So these were the two types of schedules that we supported. So there are cron-based schedules, like you say that you want to run something 10 o'clock every day, or something like a fixed rate schedule, which every 10 minutes or an hour or per day sometime. So all these were the two types of schedules that we supported. And the reason being, like cron cannot be used for a fixed rate schedule because the way it divides the time. So it's always like, if you're having like, if you want to run every 25 seconds, you can't just say in the cron like star 25 and the entire cron expression, because it will execute on 25, then the next would be 50, and again it will run after a minute and at 25. So there would be a difference of the third one would be executed after 35 units, which is incorrect. So so for that reason, like most of the schedulers support like fixed rate schedules, and so that's the one we also support in our scheduler. And so currently, how you create those schedules are you have every workflow has a launch plan associated with it, and you can create which is a default launch plan, which you can create an execution through a console or Flyte CTL or anything. But if you want to run it on a particular cadence, then you have to create a new launch plan for it. And this is how you actually create in Flyte. So if he would say that some workflow that you have already defined, I'll go through an example of from the existing docs that we have. This is a simple example, just a second. I have that. Okay. Yeah, this is a simple example that currently we support cron schedules on, just to demonstrate that. So this is just a task which formats a date time, and then you have a workflow which calls that formatter and prints it. And what the cron scheduler does over here is when you're creating a launch plan for it, you would instead of creating a regular launch plan, you would say that I'm creating a scheduled launch plan, and here you'll specify the schedule for it and what kind of schedule it is. So this is basically a cron expression, and currently what we have is every workflow that you want to launch in a scheduled manner, it can accept one additional argument, which is basically kickoff time. That is basically the time, the tick at which it gets scheduled. And this could be useful for many reasons. And we have included that as one of the parameters that the schedule function can use. And similarly, as I mentioned, like you have fixed rate interval schedules, which are also which you can create, and those will be having a fixed rate as a function, and you can specify how often you want to run it. This remains the same, how we will be doing it in the native scheduler. From the API perspective, nothing changes other than basically now we have the cron schedule expression now changes from the AWS specific format, which was the case earlier, because we only supported AWS as a platform where we could run this, and they had some specific changes or there are some customizations that they have in their schedule. So we have gone with a standard format cron scheduler, and yeah, that's the main difference in the API and how you actually use it. And okay, going back to this. So after you've created the cron schedule, is basically you'll activate the launch plan, and activating the launch plan is going to tell admin that it has to create a schedule. I mean, it has to create a schedule for it. So the current mechanism of how this is done is basically it's supported through CloudWatch rules. So whenever you activate a launch plan, it will add a new CloudWatch rule saying that this particular launch plan needs to be launched every few seconds or at this particular time. And when that happens, there is a particular SQS target which gets invoked. So there's a payload that gets sent from the CloudWatch rules. So whenever that CloudWatch rule gets triggered, the SQS queue is populated with a payload, and Flyte admin actually listens to that SQS target for running those executions. So that's how we currently are supporting scheduled workflows. With the native scheduler, now we have eliminated that requirement, and the way it does it, just an overview of how, so this I've already mentioned, it doesn't support AWS specific. We have a standard cron expression that we support. It's a separate binary that gets built, and it comes out as an independent pod. So we have a flexibility of scaling it independently. It's a very small footprint. It's also binary. It's a Go binary, it's written Go. And all the schedules that are run are pretty lightweight, and these are run through Go routines. So every time you activate a particular launch plan and the scheduler picks it up, it will on the schedule, it will create a new Go routine for it, and it will launch the function to execute that particular launch plan. It will send an execution to admin at that particular time. So it sends the execution, the schedule time as well. As I mentioned, that it's one parameter that you can send to the launch plan, which could be passed in to the execution. I think we wanted it, since we relied on a very highly available and fault tolerant system like AWS, we also wanted to have those properties in our system. So we built it for that. And also, like I mentioned, like people want to try it in the sandbox environment first before trying it in their production. So that would now be supported in the sandbox environment. Okay. So this is just an overview of some of the components that we have in the scheduler. So you have the schedule management piece, which is basically going to create the schedules for you. And so as I mentioned earlier, the earlier way of creating these schedules was you activate the launch plan that you had created, and it will go and create a CloudWatch rule for it. Or if you want to deactivate it, it will go and delete that rule from CloudWatch. Now, in the new system, this is basically managed through DB records. So we write the information about what the new schedule is, and what the expression or the interval is, and we save it for that particular launch plan. So every launch plan that you activate, the schedule management system takes care of creating or deactivating a record based on what operation you do. If you want to deactivate the schedule, you do activate the launch plan. So the launch plan and the schedule are tied together. So whenever you deactivate the launch plan, the schedule gets deactivated, and vice versa. And again, like Flyte supports like multiple versions of the launch plan. So the schedule management system also makes sure that it supports version management. So the schedule also has multiple versions of it, but at a time you won't be having more than one active schedule, because you don't want multiple versions of the same schedule being running. So we take care in the system that only one schedule is activated when you activate the launch plan. And yeah, so this is the management portion. The main scheduler portion is has multiple subsystems within it, and it uses the Flyte's control plane, which is the Flyte admin, for sending those executions, for creating those executions. So we'll just go over the core pieces of it. So the core piece is basically the GoCon wrapper. So this is an open source cron library that we are currently incorporating. It's written in Go, and it supports both the requirements that we have for supporting fixed rate and standard cron schedules. So this particular one is open source, and we have modified it a little to make sure that to the callable functions, which can actually pass we want to pass in the trigger timestamp, or basically the schedule timestamp, which none of the existing schedulers have. So we have modified the library so that the function accepts the current schedule time. So let's say that you have a schedule that you want to send to the admin. It has to be its schedule time is 10 o'clock. It might happen that you send the execution maybe after a few seconds or a few minutes because of some delay, but your downstream systems need to know what time this particular execution was created. So that's how we want this crucial time of what was the scheduled time that this particular execution was sent, and that's why we pass in that that schedule time to the function. And so for that, we have modified this particular code piece of the scheduler. And the executor is the one which actually sends the executions to the control plane. So what it does is whenever the GoCon wrapper is actually going and scheduling new Go routines based on the schedule that it has read. So it basically uh, uh, so it has read a set of executions from the schedule management system, and now it creates the in-memory routines so that it can execute those. So it calls the executive the executor subsystem to actually execute those functions, those particular schedules to in Flyte admin. So you have every 10 minutes. So that go routine gets created every 10 minutes. And the executor's job is to make sure that it creates a unique identifier for that execution based on the timestamp and the name of the schedule. And it sends it to admin. Admin immediately goes and executes that particular schedule. And so and it can run multiple. So you can have multiple schedules being running simultaneously, and each of them will be sent to the executor as separate go routine functions, and they will be independently be sent to the admin. So it becomes like easily scalable and independent in how each schedule behaves in the system. Another thing we also wanted to is we didn't want to miss any of the schedules. So for some reason, if let's say that the scheduler goes down, then we don't have the information about, like, during the time it is down, what all things we missed. So, oops, sorry. So for that reason, we have two subsystems over here. We have the snapshotting system and the catch-up system. So the snapshotting system's job is to run as a separate routine, and what it does is just stores the information of what is the current state of the schedule. So if it's running every minute, it will just update a timestamp saying that I executed at this time, and it will update an in-memory map saying that this particular schedule executed at this particular timestamp. And this map of the schedule and timestamps is then saved periodically into the DB, so that let's say that the scheduler goes down for a few hours, you can still come back and read the snapshot and try to catch up on those schedules. So because it knows when it executed in the last time using the snapshotter, and the catch-up system helps in that way, that it will read that snapshot and schedule all the missed schedules during that downtime. So it will execute from the last snapshotted time to the current time. And only after that will the GoCon wrapper will schedule the next set of execution from the time.now. And another thing was, like, in order to minimize the footprint of the snapshotter, this footprint of what gets saved through the snapshot, which is basically a map of the schedule and the timestamps. So we rely on the binary format of storing it, so that it's compact instead of storing it as a JSON or any other format. So so in the database, we store one record saying that this particular at this, so we execute it every few minutes, or like every 30 seconds, and the snapshot is taken, and the snapshotter is explicitly running as a separate Go routine, and it updates updates the DB with all the schedules timestamps. And yeah, and the catch-up system is as I mentioned, like, when the scheduler comes up, the first thing that it does is it runs the catch-up system. So going through all the schedules, it needs to understand, is there anything I need to catch up? And until those all schedules are caught up, it won't start new schedules through the GoCon wrapper. So the catch-up all system is the one which takes care of doing that. So it utilizes whatever information has been saved by the snapshotter, and additionally, whatever is saved by the schedule management system. And it decides which are the schedules that it needs to send for execution. So yeah, so those are the main components that I had over here. I'll just go over like.
Hey, Praful, I had a question about the catch-up system. So the catch-up system starts in parallel with the actual executor, right? Because otherwise you might delay executions. New executions that should actually happen, let's say at the point, you were down for a little bit, but when you come back up, you will prioritize the new executions, right?
Right. So the executor is not a separate routine. It relies. It's used as a library. So executor is available when the catch-up system is running.
Okay. Yeah. I guess because when you said that we don't run any new executions, still we run catch up. That's probably confusing. It's like we'll run new executions, but we'll in parallel catch up the older executions. And this relies on the property that all executions can go in parallel in the worst case.
Yes. Okay. So some of the failure scenarios that I want to just go over, just browse through. So if the schedule time execution fails, like let's say the admin is down, it cannot accept any executions, or it fires an execution, but somehow it fails. So what we have is retry mechanisms built into this every execution that you send to admin. So there are certain configured number of retries that it does through a backoff, and if it fails, then again, like it tries to attempt to retry until exhaustion. But it is possible in a scenario where you have like a piled up schedule where you have two timestamps T1 and T2. So T1 fails, and you have and it's trying to attempt to send an execution to the admin, and you got another schedule time T2 for the same schedule, but that succeeds because for some reason, due to some grace, and so the order in admin could be T2 and T1 executions can come out of order, but the schedule time still remains intact in admin. So admin does know the actual timestamps of the executions. Another thing is like if the scheduler goes down, this actually we went through that. So we have the catch-up system, which goes through all the schedules with the last snapshot at time, and until time.now it will go through all of those. Another one is if the snapshotter fails to record a timestamp, record some snapshot, and it has an older snapshot, still the system will behave correctly. What it will do is from the last snapshot at time, if there were certain attempts made during the last execution or the last system uptime, it will try to send those executions again. But we rely on the idempotency aspect of the execution because the execution itself is uniquely identified by the schedule time and the identifier of the schedule. So it includes the schedule name, the project domain, everything regarding all the context for that schedule is there in this identifier, and along with the schedule time. So if admin knows about it, that I have got this execution already, based on that uniqueness criteria, it will send a failure back to the scheduler. And currently the behavior of the scheduler is to ignore this error and do not retry, so that it's aware that the schedule already is there in admin. So that's how it will be able to run through any of the missed executions as well, and not worry about any duplicates being sent. Next is like you have scheduler being down. Again, like if you have something that during the downtime something gets deactivated or activated, we just go by the last state, and if it's deactivated, we'll remove the schedule from the scheduler and once it's up. And if it's activated, we will just use the new timestamp from which it will start executing, sending new executions. It won't send, it won't try to attempt any of the sending any executions before that timestamp, before that updated timestamps. Another one is multiple instances. This is already covered over here, where we rely on the idempotency itself. So you can have multiple instances of the scheduler being up, but the execution identifier itself will throw out the execution, and if it exists in admin. Yeah, this is system down scenarios is similar to that. So only the scheduler being down, we rely on the catch-up system. Flyte admin being down, we rely on the retries on the go routines to make sure that the execution goes and is reattempted, assuming that admin is not going to be down for like a long time, but we can make it configurable so that right now it has a fixed number of retries that it goes through, which are enough according to what we studied. But if yeah, something like what happened yesterday with Facebook, if something like that happens, then we probably can expose like a configuration which can increase the number of retries. Or in the future, I'll also explain that we are planning to have a dead letter queue, which can be used for attempting those failed executions, schedule executions. We also support both the scheduler and Flyte admin being down. This also is supported, and the catch-up system will take care of it. And the future enhancements is basically more intelligent retries. Currently, we just have retry on all attempts. So that's the one we want to target. And the other one is basically, as I mentioned, about the dead letter queue. In case of retries being exhausted and we have some certain mixed schedules, we want to create records which can then be retried later, maybe manually or through some triggered job, which can read this information and then send those missed schedules to the admin again. Another one is separating the DB or the schema. Currently, it's co-hosted. I mean, it's a separate pod, but it's still currently using the same database and the schema. But we can plan to move to another schema or DB if as like a microservice architecture where you have your own DB. So that can be a separate feature enhancement that can be done. Yeah, that's it from, I think, from me. I was facing some issues. I wanted to show a demo, but let me see if I can get something. Yeah, I think this might take a while. So, Ketan, while we're talking, like, we have any other things that we want to add for this?
Not from my end. We should open up for questions if anybody has. I think I'll add one thing. So when we started Flyte, we actually talked a lot about writing our own scheduler, and we constantly decided not to do it because it's not a simple and straightforward problem that many folks make out to be, because we do not want to ever have missed schedules, and that's a very tough guarantee to provide. And so it on its own is a full distributed system that exists and runs, and making it fault tolerant and reliable was a big exercise. And Thank you for Praful for the contribution.
Thank you. So you can see that Flyte scheduler comes up as a separate pod. We can rely on just one instance, and it waits for the admin to be running. So only after admin is up, does it run. Okay, so everything is up. So I've already have serialized examples. So this is the LP serial examples that's there in the document. So I've just modified it to just launch it every minute. I'm just gonna, I've already have a serialized version of this, which I'm gonna register. This is, okay, so get launch plans. So this is the cron schedule that we created, which is going to execute every minute. So I mentioned that we have to activate that launch plan, and that should start executing it. So this is how you do it from flytectl. So just, it takes a minute for this one to schedule a new execution. So right now there are none. Yeah, another thing mentioned over here is, yeah, we also publish metrics from this pod, so they can be monitored and visualized. Okay, so you can see over here that successfully added a schedule, and it also fired a new schedule. So you should see a new execution here. Okay, started running. It has a scheduled time, and so this is going to run every minute. The next execution would be 1635. And yeah, I think that is the minimum granularity that we have. We don't have per second granularity. It's currently, yeah, so you can see the next execution got triggered at 35. Now, another thing I wanted to show, like we can bring down all the pods, not all the pods, basically the admin pod and the scheduler pod. So I'm going to just delete those. What the hell?
That was very brave for a demo.
And you're deleting them constantly.
Yeah.
So, in a while loop. Wow.
Yeah, I've tried this. I hope it works. Okay, I'm deleting the scheduler as well. So right now, oops. So because it's unhealthy, I can't get any executions or get any status from the admin because both the scheduler and the admin are down. So this relies on admin, but we don't have any data from that. So, so we're time to actually stop this so that.
Stop the madness.
Yeah. So. Okay, scheduler is coming up. Okay. You can see the 35, after 35, you got the, from the downtime, 36, 37, 38. Those got scheduled every minute. We didn't miss anything. And also, I think the new ones will be scheduled. But yeah, so this is where the catch-up system ran. Catch-up caught up with the schedule, and this is the new one which got fired after the catch-up system ran. So now see it. So this 38, I think, was the new one. Yeah, this was the one which was after things were caught up. Yeah, I think that's it from my side. I think was the demo.
Awesome. Thank you for the demo. Actually, that hopefully helped a lot of people. I want to add one more thing. So the Gojek team actually helped. They were very brave when they took the code from the pre-checked in branch and they ran a big load test on it, and it worked pretty well under thousands of workflows constantly being run through the scheduler. So it's almost ready for prime time.
Yeah, this will be available in the current release, and it will be available in the Flyte sandbox and can be used in any other cloud provider, even the existing AWS ones. We plan to use a native scheduler if things go good.
Yeah, not only cloud provider, you can use it even on-prem. It's essentially.
Yeah.
So obviously this is new and it's a tricky, hard problem. So play with it cautiously at the beginning before you really rely on production deployments for it. But we believe it works, and we've got some data that Gojek has helped us sort of validate from their point of view that it works under a heavy load test. I'm sure we missed something in our testing, and there'll be some small problems later on. So don't be cautious, but we are optimistic that it's essentially theoretically correct, and there aren't any problems with it that we can't fix if we find them, we know about it. So we believe it's ready, but it's new code. So thanks, Praful. That's awesome.